3 standard deviations. I want to go back. We can do this, of course, if you want. We can come back. What number is this? 9. I want to look at this one that popped up after 12. Very important. Okay. Who would like to help with this one?
I can read it.
Okay.
The population of current statistics students has ages with mean
Mu and standard
mean
deviation
mu
sigma.
and standard
Yeah.
deviation sigma.
Yes.
Samples of statistics students are randomly selected so that there are exactly 37 students in each
So
sample.
in my notes, I have n equals 37 right away. Okay.
For each sample, the mean age is computed. What does the central limit theorem tell us about the distribution of those mean ages?
Good. So we are looking at 37, which is a number definitely greater than 30, right? So the part A, who would like to comment on part A? Is part A correct? Anyone I haven't heard from today, please. You're saying B?
C.
You're saying C. The standard distribution of the mean ages can be approximated by a normal distribution, mean mu, and standard deviation. Correct. This is wrong because it's not divided by the square root of 37. I can never say precisely. And because the central limit theorem does not apply. No. Oh.
You had B selected.
I had B selected. Sorry about that. Good. So at least we know. Good. Anything else? There was something else that popped up that looked interesting. We have to look at examples like this one. Anyway, there is something else in there. Okay, never mind. Maybe I'm wrong. Okay. So my turn to select. I want to select this one. So we have a simple random sample of size n equals 64 from a population that is skewed right. So we know it's not normal, guaranteed. So mu equals 71 and sigma equals 24, but we have a sample size of 64. Describe the sampling distribution of x bar. Right? So because n is greater than 30, it's 64, I will describe x bar, sampling distribution of x bar. Let me make sure. I had to stop sharing. So describe the sampling distribution of x bar. Correct. Okay, so x bar is approximately normal with a mean 71 and a standard deviation, or standard error of the mean if you want, divided by the square root of 64. Why? Because n is greater than 30. So the distribution is uniform. No. Who would like to select for us? Anyone? Okay, I don't see who is there, so let me call on Alex.
Is it B?
B as in boy?
Yep.
So let's stop for a moment. Look what I wrote.
I was going to answer before you called on, so I think it's D.
Of course. It is approximately normal. Of course. Good. So please pay attention. Please, it will be more difficult for you to learn it outside of class than pay attention. Please. Find the mean and standard deviation of the sampling distribution. So now they're back calling it the standard deviation. But sometimes they want to call it the standard error of the mean. Fine. Okay.
Would the mean just be 71?
Absolutely. We wrote it. And the standard deviation, can anyone compute for us? They say
It's
type
3.
integers or decimals. Say it again.
It's 3.
It's 3. Great job. Everyone understands how we determine the 3? Please say yes or no.
Yeah, you divide 24 by the square root of 64.
Okay, perfect. Great job. Okay, moving on. Now, we are asked to determine the probability that x bar is greater than 74. So I'm going to stop sharing. So the probability that x bar is greater than 74. I have several options. One of them is normal CDF from the leftmost point to the rightmost point, which is infinity, comma, the mean, which is 71, comma, the standard deviation, which we already calculated to be 3. So if we use the calculator, we are going to use normal distribution, normal CDF, greater than, so this has to be 71, to infinity, that's correct, mu, 74, standard deviation 3, and that's it. And that will be our probability. From the leftmost point till the rightmost point, mean and standard deviation, and enter. So we get the probability 0.84134. Let's see how they want the answer. Round to 4 decimal places. So 0.8413. What am I doing? Where is the 0.8413? The next question.
Oh, I have a question. Why did you use the lower bound as 71?
Did I type in 71?
You typed in 71. Was it supposed to be 74?
Of course.
All right.
Of course.
I have it right here.
Of course. I'm sorry. I reversed these two. Sorry. Sorry. Of course. From 74 to infinity, mean standard deviation. Yes. Very good. Is that what you get?
Yes.
What you got? 1587. Of course. Where am I? I'm here. One, 587. Of course. Good. The second question, what is the probability that x is less than or equal to 63.8? So the same thing, probability that x is less than or equal to 63.8. I'm checking just to make sure. Yes, correct. Good. So again, the same thing, normal CDF from the leftmost point till the rightmost point, comma the mean, 71, and comma standard deviation 3. So, same thing, but I have to make some corrections here, and the corrections are, I'm going to insert and just correct that later, negative E99. Okay, comma, and this is 68.3. 63.8, yes. And comma. Okay, one more time. From negative infinity to 63.8, correct. Comma 71, comma 3, that's correct. So the probability is 0.008197. Okay, so let's see how they want the answer. Round to 4 decimal places again. 0.0082. Good, and the last one, it's in between. Okay, that's even easier. I don't need the infinities then. So I'm on page 3. So let me just copy the probability that x is between 66.5 and x bar, of course, less than 76.85. Just make sure that you have here x bar. I put it on the first one, but I forgot to write on the second. So we're asked about x bar. So the same thing. Going to just copy again. So this time I have 66.5, comma, I have 76.85, and I'm going to slowly delete till I get 71,3. One more time, 66.5, 76.85, 71, and 3. Yes. And that's the probability that x bar is between these two numbers, and this is 0.9076. And now they want, what do they want? Again, 4 decimal places, 0.9076. It went in the air. 0.9076. Good. We want to look at the ice cream and then move on to 8.2, or do you have anything else in mind? Are we okay with this so far?
The ice cream one.
Yes, let's do the ice cream. Who would like to start the ice cream? Anyone? Yes, please.
It says the weights of ice cream cartons are normally distributed with a mean of 9 ounces and a standard deviation.
Yes, I already wrote that in my notes. Perfect.
Right. What is the probability that a random selected carton has a weight greater than 9.15 ounces?
So this is the probability, not for a sample, but for x to be greater than 9.15. Let's read part B and identify what it's asking us, and then I'll stop sharing and explain.
A sample of 36.
Go on. I said, see, in this case, we're looking at 36. Okay, a sample of 36.
36 cartons is randomly selected. What is the probability that their mean weight is greater than 9.15 ounces?
Perfect. So let's explain and talk about this. Here, I'm asked about an individual. Here, I'm asked about a sample of size 36. Here, I'm asked about the mean because I'm given the sample size. Here, I'm asked about an individual. I'm already told that this is normal. If x is normal, this will be normal. And I know exactly how and what is the distribution. It's normal. Can anyone give us the mean and the standard deviation? Don't calculate, just tell me and I'll put them in. This one.
9.
That's it. And this one.
0.5. I can't see, sorry.
This is for a sample. If I don't use the sample size, then I don't determine the standard deviation correctly. Anyone can give us this? Don't calculate, just tell me what to write.
Is it 9.15 over 36?
So 0.5.
Oh, yeah, 0.5 over
Yes.
the 36. Square of 36.
Exactly. So please, that's why I stopped and I emphasized. This is for an individual. This is for x bar, and I have to use this standard deviation. It's the same mean, but the standard deviation for x bar is this. The standard deviation for x is this. You understand the difference? Yes? Everyone? Okay. So now I'm going to share my screen and look at the calculator. And we can do any of these if you'd like. We can look at any of these with a StatCrunch. You choose one, either the first or the second, and we'll also illustrate with StatCrunch. So second and distributions, it's a normal. It's normal CDF, cumulative density function, and it says greater than 9.15. So the lower is 9.15. The upper is infinity, correct? The mean is 9, and the standard deviation is 0.5. And here it is. Again, from 9.15 to infinity, mean standard deviation, yes. And I got that this is 0.3821. Now the same thing, but this time I have to divide 0.5 by the square root of 36, which is 6. And the calculator will determine that, unless I'm asked to find the standard deviation separately, then I will do it again. 0.5 divided by 6. So this is 0.0359.
Can we do that on StatCrunch as well?
Yes, yes, yes. In 1 minute. 1 minute. Let's enter them, and yes. So the first one, 4 decimal digits, we got 0.3821. And the other one, 0.0359. Yes, we have to get the same answers with StatCrunch, and I think I have it ready somewhere here in the background. Maybe it will not take me out of the assignment. Okay, so we go to stats calculators. We're looking at the normal distribution. So calculator, stats, calculators, normal distribution. And we put in the mean, which, so you want the first one, part A or part B?
We do both?
Yes. So the first one, the mean is 9. The standard deviation is 0.5. We want greater than. Oh, of course, wait a minute. I haven't even put in the numbers. Don't rush that fast to draw a conclusion. Okay, so when I click compute, I have to. When I click compute, I have to get 0.3821 right here in this box. Now, the mean is this, but the standard deviation is divided by 6. Let's see if it does it. I've never done it like that, so I will see if it does it. So now when I click compute, we should get 0.0359. Good. So StatCrunch is cooperating.
Thank you.
Thank you. Okay, where am I now? Back here. Oh, well, it did disappear for some reason, or I don't know where to look for it. Ah, wonderful. Okay, so anything else from here, or we go to proportions, 8.2. We made Preston wait for quite a lot so far.